Okay, so we're going to do video number 4. This is on enthalpy. Now, that's a weird word. Like, usually chemistry, I pride it on that, it just tells us exactly what it is. So, like molar mass. Oh, okay, we're going to take the mass of 1 mole of something. But enthalpy is like one of those that's like, what? Where did this word come from? Enthalpy actually means, oh, here it is, change in heat. Okay, the change in heat. So, it's not just heat, which is Q. But now, the change in heat, we call it delta or change in. And H stands for heat this time. So we use the capital H here because it's got the delta in front of it. So I guess they feel like, hey, it's safe. All right. So what we're going to do is remember up to this point, we have only used coefficients at one point. Now coefficients were used for the mole ratio. Okay, that means mole, coefficients, right? So when we're going from moles to moles, when we can change substances, that is where we put coefficients in the only place that we put coefficients so far. So remember when we put gram mole, it's always 1 for the mole. So it's not your coefficients. But now we're going to add another place. And that is when we are solving for enthalpy, when we want to know the heat of a system here. Okay. Now heat is related to moles, and I call it molekj's. Okay. So when you're going from moles to kilojoules or kilojoules to moles, I call them molekj's. For some reason, that makes me think of Michael Jackson. I don't know. It's not really that similar, but it works for me. A molekj. So I go, okay, I'm using coefficients. So I know, though, the only place I can put the coefficients is for the mole, and then my energy will be given to me. Okay, so I will have whatever moles the coefficient. So if I have a 2 in front of oxygen here, I'm going to use that 2 or a 3 or a 1 if it's not there, right? And then I'm going to be given the enthalpy, okay, or the heat, sorry. All right. And anyway, here's an example. Now, just a fancy term, and it says it up here, is that when I give you the equation, we're used to having an equation now, right? And then we know that it balanced, or if not, we need to check. And then now we're going to be given thermochemical equations. Whoa, sounds fancy. It just means the heat of the chemical reaction is also given. So delta H, that's the enthalpy that we're talking about, for this reaction is negative 890.4 kilojoules. Now what that means is negative is telling me right away, this is like super duper fast and so nice that they do this, is going to be negative, which means I'm losing heat. Okay, so overall this will give off heat, and that is exo, or exiting the therm. So the heat is leaving the system, so that's going to be exothermic. And I know that immediately just by the sign. If it's negative, it's exothermic. If it's positive, it is endothermic, and I'm going to be getting heat and taking it in and absorbing it. All right. So how do we use this? So let's do this problem here. There's a lot of words up here in this problem. Again, get over words, right? It's just telling you a couple things, like the negative symbol is exothermic. It tells you all the things that I was just telling you, okay? And then here we have methane reacting with oxygen, and we get carbon dioxide and water. You should recognize that as a combustion right away, right? Because we're so good at that. Now, combustions can be hard to balance, but they already are here. Remember, if it's hard to balance and you're getting an odd number of oxygen on the other side, you just put a 2 in front of that hydrocarbon, erase everything, and try it again, and it will work, okay? So here we go. How much energy is given off when 2 moles of methane are burned? So there's my given. Again, remember, we always want our given. Where are we going to start and where are we going to end? How much energy, all right? So energy is going to be in the form of, in this case, kilojoules, all right? Because we have the equation. We know where we're going. So we're going to start and we're going to convert. So we know that we're going to copy down. Now, a lot of people have had trouble doing this. Yeah, it drives me crazy because really, you're just copying it. Do not change it. So some people like see this in 2 moles of methane and go, okay, I'm going to write 2 grams. No, yeah, of even something else at times. You're like, I'll just write 2 grams of oxygen. That's not even close to what this is. It is moles of methane, CH4, okay? Now, you don't even have to know the name of that, but CH4. So right away, I've taught you, please let the labels lead. We're just going to put in the labels first and no numbers yet, because a lot of people try to like, I want to put the number in right away, and then you mess it up because you're not looking at the relationship. That's what really matters, okay, the conversion. And so for mole, once I have mole, I can go molekj. Okay, that's our new conversion. And where am I going to get these numbers? Molekj, well, we just said the molekj is going to be the coefficient. So what's in front of the methane? Oh, it's a 1. Okay, so I'm just going to go ahead and put a 1 in here. And then my kJs, I'm going to go get it from my given. I don't have to create anything. It's negative 890.4 kilojoules. All right. And so now all I got to do is calculate. So I go ahead and go and I say, hey, let me start with my given. We got to turn on our calculator. 2.00, okay, times, because it's on top, negative, and the negative sign is way down at the bottom, but you can also just make it negative at the end, 890.4. Now we're dividing by 1, which won't change it. So now we have our lovely answer. It is negative. Please don't forget that, because the negative times whatever positives there will be a negative. So 1780.8 kilojoules. Now, the cool thing about this chapter is I'm not going to be worried about sig figs, because energy values are going to be like large numbers like this a lot of times, or just awkward numbers that we're like, okay, let's just go ahead and leave it. So I'm not going to grade on sig figs here as much, okay, well, at least in the Mocha J's. All right, so let's try one more. Actually, I would like you to pause the video in just a second when I tell you here, but realize, let's pick out the given is released. Now they're telling me it's released, okay, so that's going to be a negative number again, because this is released. I know my given, and again, what do I want? I want to know the energy, all right? So it's still based on that same equation, so we're going to get kilojoules again, but this time we're starting with grams. We don't start with moles, okay? So moles to kJs was just one step. This one is actually going to take what? Grams to moles, and then moles to kJs. So now go ahead and pause it, and I know you can do this, so go ahead and try it yourself, and then come back and see if you've done it. All right, so how much energy? So again, we're starting with our given, 22.4 grams of methane. We're just going to let the labels do all the work first, right? Grams of methane. We're going to copy the whole thing. A lot of you guys the trouble you're having is you're not paying attention to your units. You get bobbled. You think you know what you're doing, and or you just don't, because you're not paying attention to your units and what the substance is. So if in gram to mole, I cannot change it. I'm going to fill in that conversion later. And now we are going to go, again, mole, since I have not got to the energy, but once I have mole, I can mole kJ. And now that is about methane. I just don't have to put that as my unit. I got two relationships. This is going to cross off, and then I'm left with what I wanted at the top there, ready to go. We just need to fill these in. When it's mole gram, do not start putting coefficients in here again. Some of you guys have. It's 1 always, okay? CH4, we got to add up 12.01 for our carbon, and some of you guys are still not going to 4 sig figs off the periodic table. This is 4 sig figs. Times 4, so we just get our calculators and go, okay, 1.008 times 4 is 4.032 plus 12.01, and we get 16. We're going to go to 2 decimal places because that's 3, but 2 is the least, 04. And then this is even easier over here because mole kJ, coefficient. So it's going to be the same. We're going to take the methane coefficient of 1. That is a coefficient and not just a 1 that we put like over here. It's different, okay? And then kJs, again, just plugging in that number, 890.4. And then we're only left to do our calculating. We're going to start with our given, of course, 22.4. We're going to divide because it's on the bottom, 16.04. And then we're going to multiply by negative 890.4. And we get our lovely answer. Love that I didn't leave a whole lot of space. Negative 1243.45. Now you could go just a little bit out, but I'm fine with either that. Or you could go to sig figs, which again, I'd say this are a lot tougher, is negative 124, but then the 0 gets to hold the place, so 1240 kilojoules, okay? But I'm fine with either answer. All is good here. All right, so you got your whisk. So let's whisk off and get that done and ask questions in class as needed.